So, let's start the second lecture. So at least, well, most of you came back for the second lecture, so that's good. The first exercise assignments are already online, so if you are wondering what type of exercises they are, they generally follow the pattern that the first one is about some technical tool or assignment to do something with source code, and the second one is about write a technical essay on the topic that was covered in the lecture. You also might ask, what is a technical essay? It's a short writing where you answer to the questions about the topic, try to find references, and also give your opinion on the topic. It doesn't have to be something out of encyclopedia. It can also be something that what's your concern discussing the topic. But anyway, they are now on Moodle, so go there and check that out. So we are still in the software maintenance course, and yes, I'm still Jussi Kasurinen, so let's get to the actual topic. So we started last week with the discussion over why maintenance. Why do we need to talk about software maintenance? And also what sort of things are related to the maintenance aspect in general. On this week we'll go further with that idea and talk about software quality. Because of course we do maintenance to keep things running, or we do software development to produce something. So it should aim towards some objective. So of course what these objectives are, and also what the software quality is. For example, last week we talked about this. So more or less every time we are developing something, we are making a system. It might be a software tool, it might be a service, it might be a mobile app, it might be something completely different, but still it more or less has the same things. It has the database connections or the cloud connections where it can upload and download its resources. It has components, it has objects, it uses sends messages between its own internal parts to get something done. So overall, when we want to launch the product, we just check that everything more or less works as intended. On the acceptance testing, that's more or less the idea behind it. On software maintenance, on the other hand, these the requirements, for example, to run the system or to run the software change. We might have to add new features or tailor the program to fit for a new customer, so these sort of things. So basically, what we have in acceptance testing is actually the first iteration of the product. And on the maintenance, we do the rest of the product until we decide that it's too old-fashioned or too legacy, or simply too convolved that we can't keep it in maintenance anymore. So basically, what was introduced last time was that earlier on the software engineering, the acceptance testing was more or less the last step of the process. Whereas on the software maintenance and software maintenance related topics of software engineering, the acceptance testing is actually the first step of the maintenance cycle. This is a thing that we more or less know that it works. It completes all the requirements, or at least those requirements set by the customers. So this is the first step. So from this day onwards, things change, and we try to keep the system still functional enough so that it fulfills its purpose. So considering the latter part, the maintenance and end of support, we have to keep doing the design the development and quality assurance work. Even basically these three things here, but they are no longer a separate thing, or it's not this sort of pipeline. In the maintenance, we do small projects to ensure that everything still works. So of course, on this aspect, we talked about maintainability. How do we ensure that the system actually functions, or how in the maintenance, or how can we ensure that it's easy to fix, easy to make all these changes, or how do we actually measure that we are going towards the right direction? This is where the quality and the definitions of quality come in. And overall, also, what's the aim of our maintenance work? So let's skip ahead to this slide. So of course, there's different types of quality, but for example, from the viewpoint of maintenance, there are several different things we could do. The corrective maintenance, fixing errors we found, or emergency version of it, meaning that we just try to keep the things running without having a much thought on the how it is fixed, as long as it still works, or adaptive maintenance, where we are making changes or ensuring that the system still works, even though hardware, software versions, something changes on the fundamentals and foundations of the software. The perfective maintenance, of course, is the thing that's mostly known in the games industry. I wonder why this started to act on its own. Well, let's try to fix it a bit. But the perfective maintenance or additive maintenance, this additive maintenance, by the way, is added by me to these categories because that's not, I think, formal term in the industry standardization. But this means that we are trying to adapt to the new user requirements. Of course, the easiest way to understand this is that if you are, for example, a retail chain, your logo and information is correctly printed on the receipt. Or if you are a game developer, you need to keep the game fresh and updated so that your customers who are using the free-to-play game have always something to do so that they don't leave your company and give their money or add the revenue somewhere else. This is basically a basic reason why we do maintenance work. And finally, the least liked maintenance type, the preventive maintenance, means that we fix things before they get broken. We do module or code refactoring, or try to simplify complex parts of the system, try to make managed or controlled hardware changes to cater to a larger customer base in the future. For example, when the Netflix was doing the migration from the then used cloud system to the server cluster system to the container-based solution, that was actually preventive maintenance in a sense that they made the changes before the system before it fell apart. Anyway, so software quality. Software quality in relation to maintenance, of course, means that we aim towards something, and we need to know what do we actually need to fix, or how do we actually even define what's the preferred or needed quality of our product. For example, if we have games, we might have different requirements than when we are using something like an enterprise resource planning system, ERP systems. So basically, on the software engineering side, of course, there's no easy way to explain what the quality is. Well, in life general, there really is no way to explain what quality in general is. And if we take into account the quality in use, it becomes even more involved, because not only are we talking about something that we can measure, but also things like what the user likes, or how the user sees that the product is, what's the cost-value relation of the product. So this topic is the first one of actually several lectures, because of course we can't always fix everything and we can't always test everything. That's one of the foundations of software engineering. So we need to focus our effort in maintenance and also in development to ensure that we fix the most important aspects or make the product or keep the product as good as we can. So how can we first of all measure quality and how software quality can be defined in general? So the indicators of system decay are here. This is based on some studies, but also based on earlier works on software maintenance. So frequent failures, overly complex structure, running in emulation mode because the system no longer supports the actual hardware running the things, or having very large convolved components, excessive resource requirements, deficient documentation, high personnel turnover, or different technologies merged into or Frankensteined into one system which still sort of keeps running, are the most common indicators. Of course, these 8 elements can also be grouped into larger groups which sort of summarize these things. For example, if we consider purely technical issues of the system, the very large components usually means that there's so much bloat code or something else, support code or backwards compatibility to the systems which might no longer even exist, that the maintaining the system is actually quite a hassle. No one is certain on what's there or what is needed and what is not. Also, the complex structure is also something. If we add hotfix or hotfix and hotfix and hotfix after each other, we might end up with something that's more or less held together with band-aids. And also, if we don't have the documentation and know what is actually needed, we end up with a system which has low cohesion and high coupling, which is a problem because then you can't change just one module. Finally, like I mentioned, running in emulation mode means that we can't give direct support anymore, so that's going to be a problem. So these are more or less technical issues which rise throughout the software lifecycle. On the other hand, there's also management issues. The brain drain, for example, high personnel turnover, means that the system or maintaining the system is such a hell march of a project that no one who is sane and capable wants to keep doing that. Also, because we have a deficient documentation, we are or old, unupdated documentation-based wiki pages or something, internal wiki or something like that, you can no longer rely on the information available, which means that everything is much harder to do, takes time, because you have to confirm each piece of information that it actually works. So besides technical issues, there's also management issues. And finally, there's quality issues, which arise because of all the other things, like frequent failures, excessive resource requirements, or different technologies in one system. Meaning that you have problems maintaining the quality of the original product. For example, the frequent failures, they are a clear indication that something is wrong. The software foundation or hardware foundation has changed, and you can no longer actually support the software or hardware as well as you would like to. Excessive resource requirements also is something to this degree, because it usually means that your system lacks optimization. You originally didn't have enough time to do optimized solution or good enough solution, so you are just brute forcing things. This also means that you probably have one too many hotfixes on top of the system, and this is actually also something that's fairly which is fairly simple to explain by, for example, considering how the Windows Vista operating system worked. It was a real bloatware operating system which no one really actually wanted. But it was an upgrade because the markets were expecting updates, so you were given something that was less than ideal product. And it's not surprised that it was abandoned immediately when something better came along. It's also one of the reasons why Linux desktop systems became such a popular thing, because that operating system was a complete failure, but still. And also, if you are Frankensteining your system together, you also more or less have quality issues on the technical aspects of your software. So basically, besides management aspects and technical aspects, there's also general quality issues involved. So all sorts of things arise when you are having problems, when you are doing systems maintenance or maintenance in a system which has existed for a long time. So, of course, these are the three main things which all are, of course, a problem. The management issues are something that's mostly pure software engineering. If we don't follow the process, or if we don't do the rigid documentation and management and update work on all the aspects of the software, then this will become a problem and the system will fail, or it become obsolete because no one can maintain it anymore. This is the place where usually the people who are considered killjoys exist, because they demand that the programmers, for example, make documentation out of their work, or we use one cycle to just check that all the documents, all the training materials, all the tutorials and all these sort of things actually still explain the things correctly, or that the technical documentation still defines the system correctly. The quality issues are usually about the performance and the overall quality. On customer products, for example, like mobile games, it may mean some small things like it gets laggy, or it wastes battery life, or these sort of small annoyances which tend to find their way into the product during its life cycle. And the technical issues themselves are more or less about the maintainability. So the code base is bloated, the daily builds might no longer work. There's unnecessarily complex modules keeping the thing together, because no one is no longer certain that what's the actual, what is involved in what. So the code can no longer be written or refactored. It's just addition after addition after addition, and hope that it doesn't completely die on your hands. So of course, all these things need to be addressed. But we start with the software quality because it's also about the maintainability in the first place. So how can we measure quality? We know from the previous slides that we have to kill the system at some point. How can we measure that something is still fixable? Or on the other hand, how can we measure that the last patch, hotfix, content update, whatever, was one too many, or that we released a faulty update and we need to take it back and try something else? Of course, we can listen to the customers complaining, but we also all know that the customers always complain. That's just human nature. We complain. But, for example, how can we measure if something works? If we make updates, for example, to user interface, what sort of things can we measure to see that the new interface is actually better than the old one? Or the other way around, is the user interface even that important part of our product? What's the quality the customers expect? Or what's the quality that we need? And these sort of aspects. So how do we define on this project what sort of quality do we want? So, high quality. This, annoyingly, no one knows what the high quality is in any project they have ever been involved. This is just a fact of life. If we interview 10 people from the same project, they all of them give different answers. Unless we somehow define, or we have defined already, that this is what we want. These are the measurements, these are the metrics, these we will follow. This is the basis of our decisions. Because everyone is looking at these things from their own perspective. Programmer likes lean and very efficient code. Marketing people require that the product is made almost next to nothing, and the customer likes it, so it sells well. The managing director might not care about these aspects at all, as long as the product is out, and so on and so on and so on. So we have to define what the high quality is. And of course, there is no absolute quality ever. We can consider different aspects, like the end user usability or the quality of the built components or these sort of things, but there's still different ways to define high quality, and no matter how much we measure, we still might have an argument that this is not of high quality. For example, can a product with a faulty design be of high quality or of good quality? Some might say that it can't, but on the other hand, the French army in the First World War designed a machine gun, which, to be completely honest, was a complete piece of crap. But it was cheap to manufacture. They could dole out them for everyone, even the volunteering forces. So their rate of fire was comically upgraded from the early rifleman companies. So some say that that piece of crap, which actually had a problem with that it had an open mechanism, meaning that all the dirt got into the gun and you have to keep cleaning it all the time, and it still misfired continuously, wasn't a very good machine gun. But it won the war for the French. So, of course, if it's a weapon that wins you a war, of course it's a high quality at that point. The manufacturing quality might be adequate. The overall quality or usability might be completely horrible, but still, it was a product that won the war and was better than something that was available before that, or was better than the competition available. So, of course, it was the best machine gun available on that volume at that time. So, by default, it has to be of the best quality available. Also, can a product which keeps failing be of high quality? This is about image marketing. For example, I have owned exactly one pair of Versace shoes. They were expensive, yes, but they were on very deep sale. They looked really good. Of course, they are high quality. They are high quality shoes. They are fashionable and so on and so on. They were absolutely miserable shoes in every possible way. They were uncomfortable. They made blisters on my feet, and they actually fell apart after a couple of usages in work-related things. So considering that they kept failing as shoes. But I can guarantee you that if we put those and supermarket sneakers next to each other and ask people which of these are of higher quality, the Versace shoes will always win that, because they are conceived as of higher quality. And they sort of are of high quality if your main function is to just go from one jet set party to another. But still, as shoes for people who actually have to walk for a living, they are completely miserable product. So on these both occasions, a faulty design, gun that keeps jamming, or shoes that are uncomfortable are of high quality in a certain way of measurement. They are also of poor quality abysmal quality with the other measurement. But still, we cannot say that they are bad products. Neither the French machine gun or the Versace shoes, because they have qualities which make them excellent. So, there's a couple of general definitions of quality. The Garvin's definitions of quality are more or less the Bible stuff of software engineering. So you might want to look that up on Google Scholar. The first quality is just the definition, is just a transcendent definition. So quality is something that you intuitively understand. You really can't explain why you like something. You can't explain it. It's beautiful, you love it, whatever it is. But that's one definition of quality. It's nothing more complicated. From 0 to 10, how high quality do you consider this to be, and no explanation given. That sort of transcendent quality. You have an idea what is good, and you follow that instinct. Of course, the product-based definition is, on the other hand, is that quality is found in the components and attributes of a product. So, is it capable of doing everything you want? Does it have enough output, throughput? Is it energy efficient enough? These sort of things. So, is it as a product or collection of things that you need the product to do? Is it doing it well? Is it, on this definition, basically the attractiveness of the product is also somewhat considered, but it's not that important. For example, the product may look horrible. For example, like most of the innovations that came out from the Soviet Union, the appearance wasn't actually the first thing everyone considered, but still, as product, some of the things actually worked very well. So that's a sort of a product-based definition. Of course, the third definition then, the user-based definition, means that if the customer is satisfied, the product has a good quality. So if the customers love it, it's good or good enough. Even though the customers might not actually know what they could get with the same amount of money, or if the customers are not really capable of comparing this and that together, still, if the customers like it, then it's good quality. These sort of things are usually very common in entertainment software and entertainment industry. Of course, for example, consider movie. If your viewers or people who go to cinema or rent it or use some Viaplay or Netflix or other thing to watch your movie, love it. Of course, then it's a good movie. Even though it might have what some might say piss poor acting, or it was shot in location which is on someone's backyard, so sort of B-movie, these sort of things. Like the early seasons of X-Files, everything happens in a dark warehouse because the production company didn't have money to actually build a set for things to happen. So they're always on some dark basement or somewhere else because they really didn't have money to show that this is a basement of a local high school building. But anyway, if the users love it, then of course it has to be high quality. And who are we to argue about that? Fourth, the manufacturing-based definition. So if we have a product which fulfills all the definitions of it, we have defined product, we know what the customers need, and we actually have all the design specifications set. We make the product, it conforms to everything. Of course, it has to be of good quality. This, of course, means something that's probably usable in engine parts and that sort of stuff. You really hate the situation where the airplane engine falls apart mid-flight because the spare parts were crappy. Or something to that degree. But still, it's a valid definition. Of course, I don't personally care if I can take this phone to outer space or not, how well it handles vacuum and stuff like that. But still, if I buy a phone which is said to be able to be used on outer space or in vacuum or make a phone call from the bottom of the ocean, of course, if it's that solidly built, then it's probably very good quality. And if it follows all the definitions that it needs to do, then of course it's the manufacturing of the product is of high quality. Also, something simple like screws or nails or boards or whatever. These sort of small items which you need every day. How many failures per hour or per 10,000 products made you have? That sort of quality is something that you can also follow. And finally, the value-based definition. This is a bit different from the customer point of view, but it still more or less follows the general concept. This means that if it's a good value for the price, then it's good product. Of course, if you pay more, you always get something more. Well, usually, or otherwise you are getting ripped off. But if you are paying more, you generally tend to have a better product. But of course, there's also very good things which are not that expensive. For example, with mobile phones. It's a classic image marketing area. The iPhones are hideously expensive, even to people who have relatively well-paid jobs. But still, people keep lining up to queues to actually get one. That's because of the impression they have. They think that it's best thing ever because it's an Apple product. But on the other hand, some other people might buy €200 phone which runs Android because they see that it has a better value-based quality. It does all the same things. It might need more technical intuition to actually keep it functioning, but still, it's a very good value for the price. This is also more or less the reason probably why, for example, military surplus stores are doing well nowadays. People get the impression that the army and law enforcement and this emergency service stuff is somehow of great quality because it's so rugged and durable even. But nevertheless, if it's cheap enough, it's probably of good quality because it has such a great value. So all these things approach the same thing, quality, from the different directions. But still they all are equally important. Also, considering that we are actually talking about software industry here, not about screws and blanks or something like that, if we consider instead of product a service. So on this example here, we can find sort of an explanation of what type of fountain pen is very good for its money or fulfilling any of these criteria. But for example, how about food service? What sort of things are we expecting from service and what sort of things are we expecting from product? How can we measure a service? Usability aspects, these sort of things, or the different attributes available. So the service industry or the service quality is about the quality in use, because if we don't have any customers or we aren't doing anything, we aren't providing a service, whereas the product itself is something that can be measured simply by it existing. So of course, if we are talking about software, we also have to consider this side of the problem. So first of all, the quick engineering answer is that of course we can measure things. Let's collect metrics. Decide what of these things, what of the measurements are important, and keep watching them and try to increase them, enhance them as long as we can. In general, we will come up with something like this. So we have to consider also the possibility that we might actually have unnecessary changes, or that based on customer reviews or customer information, or about information about the decay of the system or the state of the bugs or stuff like that, it's actually too costly to fix things or change things. We just leave it as it is. So this is about maintenance aspects. Because first of all, of course, we need to have a product that's not useless. It has to be useful. At this point, we still have something that's serviceable or sellable, as long as we don't spend too much money on it. The competitive aspect here means that it's something that still sells or is good enough that people might actually consider it against its competition because of some reason. Finally, on the saturation breakpoint there, we talk about excessive. Of course, excessive quality surpasses all the requirements or expectations and these sort of things. From the customer or user point of view, we of course want to have excessive quality. We want to have things that are so perfect that we don't have any complaints about the product. But on the software maintenance point of view, there's really no point of fixing something that isn't really broken. We know that there is a problem there somewhere. There's always bugs in the software. There's always problems with the system. There's always something that we can enhance from the service. We can make things more simplified or simpler. We can always make the system answer or react to user input with a smaller lag or these sort of things. But still, we might not actually have to do anything. Or the best action is to not do anything, because in software maintenance, this is also something that's completely viable option. It still sells well. There's really no time or money in it. We are maintaining it just so that our old customers stay happy. So we are not going to fix these problems. This is all, yet again, very common, for example, in the games industry. You might even see a release of old games in new platforms, in new sales venues, like old games released in Steam and good old games platform, and they still have the same problems in them, because the only things that were worthwhile doing as a maintenance cycle was increasing the compatibility with the new platform, or building the virtual box or the emulation system which runs the game in a modern platform, but not fix the game itself, because the bugs in there are something that it's not worthwhile, or it doesn't pay to fix those things. Of course, if we want to go through these marketing people things, the idea or the ideal is this. We do quality assurance and quality control, for example, with the patches and also with the acceptance testing and these other things, mainly because it's cheaper to fix things before they become problematic. Of course, in maintenance, this already is a problematic thing, because we already have a product that's launched. But on the other hand, in this aspect, the quality cost should be considered, how much it costs to maintain the existing quality, or how much it costs to ensure that our fix or patch isn't broken. On last week's lectures, I mentioned that even high as 1/5 of all patches are things that actually introduce new problems to the system on some occasions, or 5% in more rigid systems. But still, is it worthwhile to try to fix things? Because you may end up with a system that's broken differently. And these are the things that you have to measure and find out as fast as possible, because, for example, in the continuous deployment, the idea is that if you release something that doesn't work or is bad for your system, you just take back that daily build and try something else the next day. This is the philosophy behind it. You don't spend time trying to fix your old problems. You just delete or take back everything that makes the entire system worse. This is also something that you need to measure, because how would you otherwise know what's better and what's worse? So, what do we then want to measure? Lucky for you, there's a shit ton of things we can check from every software. Like I mentioned earlier, if we ask, for example, something simple, like 10 people working on the same product, ask them what are the 3 most important attributes from this slide. We will not get even one same answer on those people. Couple might select the most important one as the same attribute. Couple might have the same 3 things, but in different order, and these sort of things. And what is actually really alarming is that this result was gained when we used only the high-level attributes, not the low-level sub-attributes, but the high-level attributes. So if you are running a project, or designing a product, or designing a user interface, or ensuring as a quality control manager or whatever, a person responsible for not screwing up the product, you have to know what you want to measure. For example, on the basic quality characteristics, functional suitability with something like functional correctness or functional appropriateness or performance efficiency, do we have the capacity or the time behavior? Does it respond fast enough? Compatibility with different things, usability in general, reliability, security, maintainability, and portability. These are all aspects which might or might not be important. Portability is usually something that's fairly considered that it's not that important. But on the other hand, on some markets, it's actually very, very important aspect. You simply don't have time, for example, to make some game or mobile app 3 times. You make it once and then port it to other systems. If your tools or any other technical solutions don't actually support that, then you are royally screwed against every other competitor you might have. In any way, because this is an international standard, of course these things defined as different characteristics of quality are also something that you can measure. You might have to use some customer interviews or use some soft heuristics, but still there's a measurement for all these different things, so you just need to pick the ones you want to use. And this is actually what I meant earlier. This is from our research group's own paper. It uses the older version of the standardization. That's why it might have some different terminology, but it's fundamentally the same thing. If we ask 30 people, what are the 3 most important quality attributes of software products, you get statistical noise as a result. There is no one important quality aspect. But still, only 9 assessments out of 248 assessments of is this quality attribute important in your opinion. Only 3.6% of these answers were that this isn't important aspect in our product ever. So of course all these things are measured. And this of course means that since we cannot have absolute quality because the quality definitions are not absolute, this is only perceived quality. So the good quality is really a myth. You can't rely or expect people working for you or your customers or your supervisors or anyone else to actually have the same idea about what sort of quality you want than yourself. If you are the person responsible for deciding what are the things that we will fix on this maintenance cycle, or what are the attributes that we are going to add, what sort of things are we going to focus in, you really also have to know what sort of things you need to have on your product. And of course, because the things aren't this simple, the same standardization also has quality in use characteristics. These more or less are about service or about using your product. So effectiveness, does it do what it's meant to do? Efficiency, how good at it is it at doing things? How satisfactory are the things? Are the customers when they are using your product or service? Freedom of risk, does it take into account the different environments, the economic risks? Does it throw out your credit card information everywhere? These sort of things. Or context, is it actually something that can do all the things that is expected from that sort of service or product to do? One example of the context being badly covered is, for example, the mobile application for Reddit discussion forums. Unless you upvote your own messages, there is no way of checking or keeping an eye or easily on the discussions you commented on something. Well, you have to favorite them or you have to vote on them. But on the other hand, why can't you just check that what messages have you sent or what sort of things have you mentioned before? So this is a feature that's missing, so it means that in this context, the discussion application is missing a feature. You can't check on the things that you found interesting enough to mention something or explain something to some other people. So, of course, the ISO IEC 25010, the square model, or the one preceding it, 9124, if I remember correctly, is of course not the model to end all models. It's not a thing that can measure everything. For example, here we can see that some factors from usage environment, primary users, target data, target software, information system, human-computer interaction are measured, but of course it can't define everything. It can measure the product quality, it can measure the data quality, and it can measure the quality in use, but of course it still doesn't cover everything. But nevertheless, it's the one which is most used in software engineering. So even if you never intend to use this standard anywhere, you might want to be aware of what it includes or how it defines different aspects of quality, because like in many other places, it might not be the one that you want to use to check your customers or make a profile out of your paying customers, but still it's something that's very well defined and something that enables you to compare things between different products even. And it's also a very common legal attachment. The definitions of what is this is based on that standardization. And finally, if we want to go into very details, I could give you an entire course about this standard itself. Because like every other standard, everything is defined to ridiculously low level of detail. For example, on this slide here, time efficiency is defined, how it's actually measured, what sort of things we want to measure, how it's actually done, how the data is collected, what sort of requirements there are, what sort of conditions there are. Same for cost effectiveness, same for all the other things. So if we went through this one by one, we would be doing this for the entire course. So we will not do that. I will leave it up to you to understand how these measurements work and how these different attributes and sub-attributes are defined. So, of course, there's some practical ways of ensuring software quality. Of course, we need to know what we want. We need to have definition of what is the quality we prefer, but it can't be denied that there are some practices, that some things that can be done in software quality in particular, that ensures that we have high quality, or that the quality stays somewhere which is relatively maintainable and keeps the system alive. So we are still on the maintenance aspect here. The quality control and quality assurance practices are not the only things that affect the quality. Of course, neither is the specification or the design aspects. Some simple things like what sort of tools and what sort of development practices we follow. These actually have a really high impact. Or when we are managing personnel in the project, what can we expect from, for example, new people? What can we expect from experienced people? These sort of things are not they're not rocket science, but still they are things that affect the software quality in the end of the day. For example, of course, there's several things in practice. So conformance to specifications, get the specs right, build according to them. That's the basis of waterfall approach. Of course, we all know that the waterfall itself isn't that hot or isn't that good approach to doing things, especially because get the specs right and build according to them. It's very easy to say, but it's almost impossible to do without any problems or any need to revise or change things in the future. So, but still, if we could do that, then that could be a really great thing. So the problem, of course, is that you can't inspect quality into a product. If you are given a crappy product to fix or maintain or develop, whatever, it's still going to be a crappy product. If it's not designed wrong, it's going to be still wrong even after you fix all the mechanical bugs or problems in it. So as a developer, you really should understand that if there's a fundamental problem or issue with the design of the product, that's not something that you can just magic away. We're doing some small maintenance fixes or some small design changes. Because testing, or well actually this should say testing or maintenance only ensures that the potential for quality stays high. But if the design is wrong, then your product is already going to fail or going to be a disaster to maintain if it's designed wrong, or if it's designed so that it's just kicked out from the door and it will never be supported for a long time. So also most problems are this says that don't blame the workers, it's a management problem. So of course bad management can always cause everything to fail. But bad management, unfortunately, is something that we will all have to live at some point with. There's even a comic Dilbert which bases entirely on this premise. So you have to believe me when I say that, especially if you are going to be a hardline developer or programmer, you will keep running into bad management. But that's probably going to be also because your viewpoint doesn't get all the things that the management has to do to keep the company afloat. This is actually also something that we expect from the software engineers. You are expected to understand how the product is developed, how the life cycle goes, and what actually can be done and should be done in maintenance, in development, when negotiating with the customers. Because like I said, you will not have money or time to fix everything or implement everything, so this is going to be a problem. But nevertheless, you will end up with customers and management which doesn't understand a thing you are doing. So, like on this example, if we have the new guy doing all the documentation and specification work, what will happen? They will miss some crucial point. They will not understand what they are doing. So all the documentation, all the things that are your backup plan when your maintenance cycle fails are now broken. So you probably shouldn't put the new guy in charge of doing the documentation. Or you can do just small things. These sort of small things ensure that your maintainability stays relatively high. Finally, Juran says that the agile approaches actually emphasize the fact that the quality is the fitness for use. So you might disagree or agree with that, but still consider that are the processes you do just something that you have to do to justify your existence, or can you change your way of doing things towards something else? This is important, for example, because an example by Toyota, how they eliminated waste. This doesn't only mean some environmental aspects. It also means things like extra process steps, weak management, or having things that are really archaic and bureaucratic in a sense. The idea is that you try to get rid of everything that makes it difficult for your team to work. If you are trying to have a process which keeps your product quality high, you need to identify all the things that hinder your work. Usually there's a couple of things. Interestingly, I have been involved in workshops with real-life companies in which we take a representative set of all the people doing the maintenance work, the development work, the design work, graphical artists, other people, maintenance, management, into the room and try to collect things which are problematic in their processes. Then we make a map and try to agree what affects what. Of course, it's a bit awkward moment when the manager, who is the root cause of all problems, is there at the workshop. But still, almost always, most of the problems are caused by something. It might be even something small like poor tools or bad management practices or too unclear chain of command. Can the design team or development team decide on different things? So if you want to improve these aspects, you have to identify them and then try to get rid of everything that's a hindrance, that's problematic or causes problems. That usually also tends to drive the quality up because it usually just kicks out the problematic things that cause the project or process to fail. Okay, so consider all these things, the quality models, the quality attributes, the sub-attributes, the different things about process activities, or the couple of key guidelines about what sort of things the developers can do to keep the quality good. A sort of toolbox from which you can take different things when you later in this course are designing on the metrics, designing on the maintainability, supported infrastructure of things. What are important things to know? What do we need to know about this aspect? What this tool offers to us? What sort of things tell us most, they reveal most information about our success? For example, if we measure the amount of customer-made actions in a web store, it might sound a bit stupid, but actually if we just measure how many things they have clicked or activated, we already know how complicated our store is to use. If our sales stay up and the amount of clicks goes lower, then the usability aspect of the store is of course going up. And it's fairly easy to see, for example, from the server side, when we have sent information or there has been request to update some form of page or something like that. So we might even not need to have the any customer-related information or information that might pinpoint to certain customer or certain event. We just check how many times there has been a data request from our server and how many sales have we had. These sort of simple things if we consider things from the technical point of view. But anyway, all these things, measurements, they are toolboxes. All the things you will see on the technical essays I'm asking you to write, you will see the belief that good process means good quality. In maintenance, in development, in everywhere. But keep in mind that there's no absolute truth, there's no absolute quality. Things have to be tailored for different environments before they can be used. So if someone comes to you and says that now drop everything, we'll go test-driven development because that fixes all the problems in the world, that person is a lunatic or lying to you. Or is a deep undercover mole from your competing company trying to drive you up for failure. Keep that in mind. Anyway, from the developer perspective, there's really two practices that support quality outcomes. And they are version control and testing work. So this, if you are purely programmer, you do these things to maintain your product quality high. The version control practices are more or less simple things. One change at a time, and then you commit. If you fucked it up, then you just roll back that commit and try again. If you committed several things at the same time and later on find out that one of these things isn't working, it's going to be a complete nightmare. Also, don't break the build. You always will need to have one build that actually compiles and is deliverable to customers. Only source files and use the log to write a summary for each commit. So what did you do? Why did you do it? Where did you do it? What sort of things you expect to happen? Or what did you test about the system? Of course, you might consider that these aren't important really. Of course, I know what I did. But keep in mind that the life cycle of a software system or service might be several years, tens of years. So it might be you, it might be your unborn child who is their first job trying to see what the PA did when they were doing university studies. So that's why you also need to have a log. And communicate with other people. I know it's really annoying when the last bullet point is talk to other people, because why would I talk to other people? They have nothing interesting to say to me, but still you need to communicate. Tell what you are doing. Tell what you are planning to do, how you are planning to fix things, because someone else knows something else about some other modules of the system. They might come up with an idea which might actually be beneficial to you, even you don't believe it at the first place. And of course, if you are a developer, agile developer, these are the things you need to do. They are taken from this larger study. Automated unit tests, don't use the quick hacks, keep it simple. Write clear code, not clever code. These sort of things that you should probably have been already told when you were doing the first programming courses. So let's not take these, spend too much time checking these out individually. But of course, these will be on the slide set, so you can check them out when you are going through them when doing the exercises. And actually, considering the maintenance work and test automation and automation suites and all the other things to ensure that you can do regression testing, there's a couple of things that you should keep in mind when you are trying to find the root cause of problems. If you are the developer, well, you can only see that the bugs are if you are doing testing to find those exact bugs. This is also the pesticide paradox. If you get rid of certain bugs, you will not get them, but there might be other types of bugs in the system existing. So always do testing work, and for example, take cluster. So if you find one really badly broken module, you usually might actually solve several things at the same time. Also, if you don't find any errors, it just means that you aren't clever enough to find the rest of them. So every time you do maintenance work, do changes on the software, you might want to consider that you shouldn't be the only eyes to test that system. That's actually one thing added to the version control, that always test your system, but always try to also use someone else to confirm that your findings or that your fix actually works. And finally, if we try to find someone to blame or try to avoid running into problems when doing the maintenance work or the development work, here's a handy list of things you probably should take care of or pay attention to. So if you are having problems in general, whether it's maintenance or adding features or doing something or developing product, new code, the new feature that was just added, the new technology to which we migrated or ported our system, the changed source code if we made changes to somewhere else, the changes we made last minute, or the changes that were made to keep the system running, emergency maintenance. That's something that you need to check and fix. If you imported something or tried to add new module, for example, for a new customer to support their web store or something like that. If you made something for the new client or for the new domain, that might be the one causing the problems. Or simply the problem was caused by a new employee who doesn't have a history or experience to know what sort of garbage hotfixes your product is made of, or is straight out from the university person who still is using some really weird ideas on what the software development is based on the courses they were given at the university. And still, the mentioned 80-20 rule, meaning that 80% of the problems are in 20% of the modules, actually might be even 99% of the problems are in 1% of the modules if we are adding something new to existing system or making large changes, especially when working with legacy system, because those things tend to be a complete nightmare. There's actually people who make good money just on maintaining legacy systems because they started doing Fortran programming in the late 80s and never really stopped. So, what do you have to remember? From the viewpoint of maintenance, well, you have to define quality. If you want to maintain your product, if you want to keep your product good or sellable or competitive against your competitors throughout the software lifecycle, you need to understand what the quality is that you need. What are the things that you need to pay attention to? The actual metrics will be discussed on the next lecture. The effect of measuring and how do you actually manage your software quality? what sort of things you can do to maintain software quality or improve or enhance your software quality. What sort of things you need for maintaining the software quality, and for example, what sort of things affect the maintenance decisions on what will be fixed, what will be done, what will be forgotten, and these sort of things. Because you will not have money or time to fix, change, or tailor everything and do everything you will be recommended to do. And finally, the first self-study assignments are online. Go check those all out, and remember, you are expected to only turn in one of them. There will be weeks or opportunities later to turn in several works, possibly. But at this point, just do the technical assignment or the writing assignment. Don't bother doing the both just yet. Also, my consulting hour is on Wednesdays. If you have problems and you are, for some reason, decide to not use the Moodle or email, I can be visited live on Wednesday in my office. I will not answer to, I will not grade email submissions. If you are having problems with Moodle, that's with you and Moodle. Contact the Moodle help or helpdesk@lut.fi. I'm not Moodle support person, so go complain to them. And I will not open or grade anything sent via email. Submit everything via Moodle. And finally, remember to register your project group, select the people you want in it, and select the open source, open access project so you can start doing them. I have only one group which has registered so far. There's 60 people here, so I'd expect that there's at least more people trying to complete this course than one 3-person group. So try to do that, because I have to remind you, only one group per open source project. There will be over 10 groups, and if everyone wants to do Firefox, then 9 out of the 10 groups are fucked, because they have to change the topic to something else. So please select your topic and register your group via email during this week or upcoming weeks. So that's that. I will stop the recording, and then you will have